This is Lab 3, Mass of a Black Hole by Michelle McIntire, Physics Lab NO3 for Dr. Schatz. In this lab, we were given position data of a star along with its mass and the location of a black hole at the center, and we were to find the mass of the black hole. So the key equation is GMM over r squared is equal to the force of gravity. And the method is we import the given data into Python and compute the magnitude of the net force and use the given data to solve for the mass of the black star. So r, the distance from star to black hole, is 1.89 times 10 to the 12th, which we got from subtracting one of the points from the data to the location of the black hole. You see our other givens also. dp is the star's mass times the change in velocity, and Newton's second law shows that dp dt is also equal to Fnet. This is our Python model, and for that we had to import the position data from a CSV file and index it to x and y for the position of the star. First thing we did was compute momentum, and that is mass times velocity. Delta P was just P final minus P initial. And then delta P over delta P is going to be dP dt. And as I said earlier, Newton's second law states that Fnet is going to be equal to the value of dP dt. Next is P hat. So for P hat, what we did is we used P initial and divided it by the magnitude of P initial. Then we found the magnitude of the change in momentum, which we just used the P final and P initial. After running this, we got this model to the right. The blue signifies the perpendicular dP dt, and the parallel is in the black arrow. The net force, or the magnitude of dP dt, is going to be the yellow arrow. We got the net force from this output in the bottom right corner. Its magnitude of Fnet is the second comma, and so I just took that from the output, which is, as stated earlier, 2.9858 times 10 to the 24th. Next thing we did was the complete analysis, and for that, GMM over r squared is equal to the force of gravity. So we just rearranged that equation to be F grav r squared divided by the gravitational constant and the mass of the star to get the mass of the black hole. So the difference between Fnet and dP dt, although they are the same in value, Fnet is going to be describing the objects that are going to be interfering and interacting with the object's motion. dP dt is a change in the momentum and thus is describing the motion. So although they have the same value, dP dt is more of a description of the motion, while Fnet is a description of why that motion is occurring. The parallel is different from Fnet parallel also in the same way that it is describing the momentum rather than the force causing that change. Okay, next is the conclusion. We found that the mass was accurate for the possible motion, assuming that that was the only force affecting it. And that value is shown here. Also, what if the black hole were replaced with another? The mass could be found in the exact same way as we just did. We would just need to upload the new position data after observing for an extended period of time. Thank you.